The crane has been a tool of humanity for centuries. They're vital for the construction of everything from bridges spanning colossal rivers to skyscrapers that reach into the clouds. Modern structures would be impossible without them, and the same has applied throughout history. Archaeological evidence suggests that the ancient Greeks invented cranes to help construct temples. It's believed a crane was used to build the Temple of Artemis in 530 BC. Obviously, they've evolved plenty since then. However, prior to World War II, cranes were far less practical to use for a majority of projects. At the time, construction cranes were more akin to ship cranes and could only be used on large construction sites. They were fitted into concrete foundations, a process that normally took several days to complete and were difficult to remove. With Germany in need of mass repair after the war, a master builder, Hans Liebherr, decided he needed to build a new type of crane that could be moved, used, and then easily moved again. In 1949, Liebherr invented the first mobile tower crane, the TK10, which took 2 to 3 hours to assemble on the job site. This was a groundbreaking innovation in both the worlds of cranes and construction that not only accelerated the rebuilding of Germany, but laid the foundations for what is the Liebherr Group as it is known today. We welcome you to this special documentary where today we'll cover the many impressive details of Liebherr's mobile cranes. Make sure to turn on captions if you want to see both metric and imperial units. The LTM 1300 is a 6-axle crane with a 78-meter telescopic boom that can be equipped with an extra lattice extension, providing a maximum hoist height of 188 meters. The crane can handle 300 tons of load within a radius of 136 meters. What sets this crane apart from traditional mobile cranes is its powertrain, which draws power from the same engine that is used to power the crane's boom. Generally, a standard mobile crane is powered by 2 separate engines, one to propel the drivetrain and the other to operate the crane. However, mobile cranes from Liebherr come standard with one engine, used for both traveling and hoisting. The singular engine is connected with a distributor gearbox that runs the undercarriage when traveling and powers the pump drive when hoisting. This concept offers numerous benefits, including reduced vehicle weight and increased space in the superstructure. It also improves balance, allowing for an increased load capacity or for a longer mount. Along with all that, having one less engine lowers overall cost, simplifies emissions systems compliance, and, most importantly, reduces maintenance complexity and costs. To make their mobile cranes more efficient, modern Liebherr machines come with an eco mode. This system incorporates new technology that automatically senses when the crane is not in use and lowers fuel consumption. If the operator doesn't interact with the machine within a set time, the eco mode automatically initiates idle standby mode by disengaging the mechanical shaft from the pump drive. The pump drive is automatically re-engaged whenever the operator decides to make an adjustment. The average crane idles more than 60% of the time during its operation, so this simple system is able to save a significant amount of fuel. If there is anything that is absolutely vital for any mobile crane, it is its stability. During crane operations, a mobile crane supports itself on an extendable steel base consisting of outriggers. The position of the outriggers determines how far the crane boom can be tilted. In tight spaces, however, the outriggers can't always be extended to their full length. Liebherr gets around this by using their vario-base system, which allows the outriggers to be extended individually. Liebherr demonstrated the benefits of vario-base by using 2 mobile cranes, one with and one without their system. The provided constricted space only allowed for a support width of 4.4 meters, meaning each crane was only able to open its outriggers to half of their limit. However, the crane with vario-base extended its outriggers by 0% on one side and 100% on the other. Consequently, it was able to attain a functional radius of 32 meters, 4.5 meters greater than with only 50% extension on all outriggers. In tight spaces, it's 12 meters longer than a standard crane.
Liebherr developed a system known as varioballast that, as the name would imply, shifts the ballast of a crane. Using a simple adjustment, the ballast radius can be changed quickly and easily, essentially moving it towards or away from the center of mass. In constricted working spaces, a narrow radius can prove to be most useful. On the other hand, a larger radius enables a crane to carry the same load to greater distances, or a heavier load outright. The GBKF is an armored mobile crane designed by Liebherr for the German Army. It's certainly a great tool, but its use is not what we're focusing on. It features the same advanced steering system that Liebherr uses across all of their modern wheeled mobile cranes. This is designed to be used in 5 different modes. For instance, different modes can be selected for taking sharper turns, turning the front or back end, or moving diagonally without turning. Every wheel is equipped with adjustable height hydropneumatic suspension, which allows the operator to adjust for driving up slopes, reduced clearance height, or for increased draft clearance. The rear axles are actively steered by an electro-hydraulic system, while the front axles are steered mechanically directly from the steering wheel. The boom of any crane is obviously essential for it to perform its functions. Most mobile cranes come standard with a telescopic boom, which can be extended or retracted as needed. Boom's design determines its telescopic speed, load capacity, and lateral stability. Liebherr generally employs one of 2 basic types of boom for their mobile cranes. These are either a rope boom with a hydromechanical system or a telematic boom with a single-cylinder system. Hydromechanical system is for any mobile crane whose telescopic boom consists of a pivot section and a maximum of 3 telescopic parts. The pivot section is the main frame of the boom that can be angled to change the height of the boom arm. The internal telescopic parts slide out of the pivot section using rope pull technology, which is based on a double-acting 2-stage hydraulic cylinder. Now, what does that actually mean? Put very simply, a double-acting cylinder has a piston with 2-way hydraulic power, so that it can be pushed or pulled. All of the telescopic sections move simultaneously. This enables the crane to extend and retract the telescopic parts faster than a single hydraulic cylinder. This boom type was designed for usage at low heights, such as between buildings. A telematic boom, on the other hand, has an automated telescoping mechanism that relies solely on a single-cylinder extension system. It also includes an internal locking system, which locks each telescopic section one after the other. In other words, each section can only extend when the section before it reaches its maximum length. The telematic boom has been in use since the 1990s. This decades-long experience is why most mobile cranes are fitted with it, rather than other modern telescoping systems. This technology is still unbeatable when it comes to lifting and telescoping heavy loads. Crane manufacturers also develop extensions for mobile cranes to meet job requirements, known as jibs. This includes the folding jib and the fixed jib. A folding jib is an extension that can be, as the name would imply, folded up and doesn't need to be taken off after use. On the other hand, a fixed jib is brought to the worksite separately and mounted thereafter. Such jib extensions provide exceptionally high hoist heights and load capacities when compared to folding jibs. The higher a boom goes, the harder it becomes to keep stable laterally. To put it simply, a heavy weight hanging from a long boom can cause the boom to bend. Imagine how a thin metal strip deforms when subjected to a force, and how a longer strip will visibly bend more than a shorter strip. A unique solution has been developed to counter this problem: the Y-guying system. 2 ropes on both sides of the boom, pulling in tension to identical lengths. This keeps the boom straight and gives it a higher load capacity. It's definitely a complicated system though, which is why Liebherr only uses it with cranes that already have a load capacity of 350 tons or more. One such crane is the LTM 1650, an 8-axle mobile crane with a 700-ton maximum load capacity. Using the Y-guying system, it was able to install a protective cover on the Riesding Rado, a satellite Earth station located in Bavaria. The total length of the crane's telescopic boom is 80 meters, on which a 56-meter luffing jib was installed. Strong blowing wind was the real challenge, as the cover was 50 meters in diameter, making it like a sail to the wind. The team calculated that the mobile crane would be able to draw over the cover with a wind speed of up to 1.5 meters per second. That's about 3.3 miles per hour. The Y-guying system kept this delivery firm, even when the load was 100 meters high from the ground. This Earth station, which once communicated with Apollo 11 to complete the moon mission, is now once again completely functional. The modern mobile crane comes standard with an intuitive control system. These use a variety of different sensors, alongside monitoring and control modules. One such example is Liebherr's Lycon system. Such a control system helps operators deploy the mobile crane more quickly. Using a Bluetooth remote control, operation setup can be completed quickly and safely. It employs advanced software in order to guide the operator in real time. A taste of the future. A VR-supported planner can be used in order to find issues and solutions in advance of the project. The LTM 11200-9.1 is the largest mobile crane in its fleet. It comes standard with a 100-meter telescopic arm, offering a maximum load capacity of 1,200 tons and a maximum hoisting height of 188 meters. In addition to that, its boom can be extended using jib extensions or a Y-guiding system, which is considered an ideal choice for the construction of wind towers. Here, this mighty machine, in collaboration with the impressive LG 1750, is raising a 160-ton top section for the mast.
Compared to a standard mobile crane, a crawler crane has the ability to move itself around the worksite, but it does so using a crawling undercarriage rather than wheels. This gives crawler cranes an advantage around the worksite by limiting the need for outriggers. Sometimes, crawler cranes are steered while carrying a load. As compared to mobile cranes, a crawler crane can haul more loads and provides extra flexibility. But that doesn't mean this type of crane can smoothly deal with any job site situation. For one, crawler cranes are unable to move along roads. Their tracks would cause damage to any road surface, particularly when turning. Thus, they generally have to be transported to a job site via trailer. Along with this, as with any machine, the working area under a crawler's track can only absorb a limited amount of pressure. Tracks are great for spreading out pressure. However, the ground around things like ledges or above underground pits can only take so much force. Exceeding this can cause subsidence, and as a result, the machine could overturn. In order to cope with this problem, a ground pressure visualization system is installed in crawler cranes. This system constantly measures the ground pressure and the exact position of all moving parts. On the control monitor, the machine's center of gravity and ground pressure are displayed, so that the operator can avoid potentially hazardous situations. Unlike mobile cranes with telescopic booms, a crawler crane is typically mounted with a luffing jib. It has a lattice jib that can be raised and lowered, a motion known as luffing, which offers greater adaptability and lifting capacity. Due to the reduced slowing radius, it is particularly useful for work in congested areas. The LR13000, with a 120-meter main boom and a 126-meter luffing jib, is the tallest crane in the world, offering an overall height of 246 meters. Erecting such a long, heavy boom is a challenge in and of itself, and keeping it straight is yet another. The higher the boom stands, the harder it becomes to keep it upright, as the boom becomes exposed to increasingly stronger winds. This can lead to tipping, which is a problem that occurs when the crane's center of gravity is not above the tracks or outriggers. This is the reason wind sensors are mounted on the top of the boom and jib. These provide real-time feedback to the system. If the situation becomes severe enough, the inbuilt AI stops the operation and brings the boom back to a safe position. It is also critical to keep the load vertically and horizontally aligned. To prevent swaying, the operator has to ensure that the boom is aligned directly above the load and must keep the rope tensioned before lifting. Moving the load horizontally while keeping it level is the real test for operators. To make this risky task less challenging, Liebherr developed a system to automate much of this work. The crane automatically senses the tension of the rope and positions the crane's boom above the load. This prevents swaying of the load when first being lifted. The control unit then automatically adjusts the hoist gear for steady horizontal movement of the hook and load. This results in quick and easy lifting operations. The LR11350 is a crawler crane with a maximum lifting capacity of 1,350 tons, a hoisting height of 220 meters, and a boom radius of 164 meters. This crane was able to lift the protective shell of one of the reactors at the Leningrad nuclear power plant. The dome was designed to prevent the emission of harmful substances into the atmosphere in the event of reactor failure, and had a total weight of 300 tons. Transporting such a massive crane to the job site and assembling it is no easy task. Liebherr designs each major component of the crane with transport standards in mind. In addition, Liebherr creates a variety of crawler cranes that come standard with the ability to self-assemble. The basic crane unit can easily stand on its outriggers and install different parts of the crane, including the crawling undercarriage, counterweight units, and winches. Each section of a lattice boom typically features connection locks that need to be aligned and locked. To lift the boom's first section is connected to the A-frame. Then, the sections of the boom are connected. After that, counterweights are mounted. The crane is then positioned in front of and connected to the main boom. A typical crane has two winches. One winch operates the lift cable while the other controls the tilt of the boom. An auxiliary winch is required to operate the luffing movement for the luffing boom. The rope of the main winch that lifts the load is led to the end of the boom. Likewise, all winches are connected to their relevant parts. Finally, wind sensors are attached, and the boom is erected by pulling the wire rope. Though cranes are generally known for their use during construction for lifting heavy objects, they do have a number of other uses. For instance, they can be used for a variety of earth-moving tasks, such as piling foundations, dredging canals, and grabbing dry bulk. These types of cranes are known as duty cycle crawler cranes. These duty cycle cranes are capable of being outfitted with slurry wall grabs or hydromills. They function as a piling rig with fixed and swinging leaders. They become a drilling rig when a pile grab and casing oscillator are attached. The duty cycle cranes are able to compact soil using tamper weights. These can also be converted into a dragline excavator for a variety of different applications. Mobile cranes have a long history of helping keep the construction of countless projects practical and safe, with Liebherr always staying at the forefront. We hope that all of you enjoyed this special documentary on Liebherr's involvement in the world of mobile cranes, and that you got to learn something about the work they do. In the future, we will be covering even more in the world of cranes, as well as the works of other companies in mining, construction, and all things civil engineering. If you have anything that you'd want to see in a future documentary, or think there is something missing from this one, make sure you let us know down below. Thanks for watching, and we hope to see you next time.